Let us continue with some matrix calculations that we can do using Numpy package. Alright, so imagine we have a set of three lists. I'm just gonna type them down. So we have 10, 15, 20 for list 1 all the way to list 3, and what we want to do, we want to define a matrix where it's an array, and when we're forming an array you need to pay attention that we need two sets of parentheses. So we are now forming a matrix between 1, 2, and 3. Alright, and then I can say print mx. So I formed a matrix that is 3 by 3. And now let's say I want to access some rows within that matrix. I can say mx, give me row 1, and next to that I can also access an individual element. So if I'm saying mx1 and then 1, that should be the value that's in the second row and the second column. So I should be able to see 30. So accessing individual elements. In addition, we can slice a two-dimensional matrix like this. So let me just say two-dimensional slicing, and the way we can do it, let's say we have called the second row, but we want to only include all the columns up to the second column but not including, or basically the third column and not including. So if I'm running this, I'm getting all the values that are in the last column, but the last row, but the first two columns. So all the way, but not including the third column. Let's run another example. I can just say, give me matrix, the values, and in the first second row onward and the second column onward. So if I'm printing that, I will get the bottom right part of this matrix. Alright. Okay, so now let's move on to some special arrays that are useful for math and statistics. Let's see what else we can do with Numpy. So we can create a matrix using the method called zeros. And I'm gonna call it matrix of 3 by 3. And that will create a matrix that has all float variables that are all zeros. I can do the same with ones, calling a method numpy ones. Let's say I just want to have two values that are in one row. This can also include values that are 4, but again, remember that we need to put them between two sets of parentheses. So that would be a matrix of 4 by 4 that all include 1. We can also call a matrix and define it as identity matrix. Identity matrix is a matrix basically that has all zeros in values and ones on diagonals. So all the diagonal values are going to be 1, as you can see. So all the values are zeros and float, and all the rest are going to be one on diagonal. And again, don't forget that when we define an array, we are usually looking at values that are similar and numeric. So these are all going to be float. Alright, what else we can do with this? Let's try to call scalar operations on arrays. Let's import Numpy again, and here I'm going to define two arrays. The first one is going to be array ARR, defined as 1, 2, and 3. And the second one is going to be, I'm just going to copy paste this, ARR1, and I will give it 4, 5, and 6. And I'm going to now print ARR and ARR1. So we see that we got these two values. Now what we can do is that we can do arithmetic calculations with the matrices. So let's say if I have two matrices of the same size and I'm multiplying them, I'm getting each value multiplied by the corresponding value. So we have 1 times 4, 2 times 5, and 3 times 6. And in the same way, I can also add these all up, or I can deduct them from each other, or divide them. So all of those, again, as long as these matrices are the same size, these values should work. And imagine if I add another value that's beyond the size of the matrix, what's going to happen is that it's going to work, whatever that's going to work, and it will leave the last value out. So when I'm multiplying them, I have 3 by 6, and it will ignore the whatever value that's bigger than the size of the matrices that are being multiplied. Again, basic matrix algebra.